Okay, we are ready for the next session, which is iOS App Security by Marco Grassi.
Hi everyone, can you hear me? Okay. So my name is Marco and I'm from Reggio Emilia. As you may notice, I'm not a native English speaker, so please be patient for my accent. And thanks for coming. We have a lot to cover, so I will just say a couple words about myself. I do research and development for a company called Via Forensics, which is based in Chicago, and I work remotely. So part of my job is to analyze and attack mobile applications. And so in this talk, I would like to give you an overview of those kind of assessment that we perform in order to evaluate the security of iOS application. How this kind of security assessment works? Well, they are mainly a black box approach, which means that we don't have access to the source code usually. So our review usually starts by downloading the application from the App Store or sideloading it from the developer to our devices in order to test it. And we do both dynamic and static analysis. So we both analyze the code with reverse engineering, or we dynamically inspect the application with other tools that I will show to you. So while I speak, if you have any question, raise the hand. So I will repeat the question and provide the answer. What we will cover today? We will cover a lot of stuff. I will give to you a broad overview. The audience is mainly of developers, so I will give to you a broad overview and the resources to go more in depth on the stuff that you are interested in. And I will provide to you real-world examples of vulnerabilities. In this way, we can exit from the theoretical-only approach, and you maybe can recognize some error that you also made in your application, and you can correct it. And I hope also to share my passion for reverse engineering for this talk, with this talk, sorry. If you want to test the security of the application, you can try this open source free distribution of Linux, which include a lot of tools used for mobile security, and it's free, so you can give it a try. The first vulnerability that we see today is the insufficient protection of the data in transit. So this error is made when you don't take enough if you don't take enough protection on your network traffic, and so an attacker can in a way or another intercept it, and so this can lead to vulnerabilities. And this vulnerability affects every user because it does not require a jailbroken device to be exploited. So the risk of this vulnerability is usually very high because often in network traffic, password and sensitive data are leaked, like we will see in the first example. Here there is a vulnerability that I found in Corriere della Sera and Gazzetta dello Sport for iOS, and it's a very trivial one because you can see the password and the username in plain text in the network traffic in a GET request. So, for example, if any one of you at the conference now in the open Wi-Fi is reading his subscription to Corriere della Sera and someone is sniffing the traffic, he can steal your subscription. And we have disclosed this vulnerability to the developers some weeks ago, but we haven't got any response. So if you receive this kind of disclosure for free from a security researcher, please listen to them, because they just want to help. So what is needed to test this kind of vulnerabilities? Well, it's enough to use some very simple tool, like for this one that I showed to you. It's enough to use TCP dump, with, which is a packet capture tool. So every packet that transits through your network interface, it will be saved in a pickup file, and you can analyze it with a tool like Wireshark, which will help you visualize and analyze the traffic that you capture. Other more advanced tools are burp or man-in-the-middle proxy, which are more tools that are more active, in the sense that they are proxies, so they do a man-in-the-middle attack. They interpose themselves through the device and the internet, and they intercept all the HTTP and the HTTPS requests. So Gazzetta dello Sport is using the same platform as the Corriere, so there is the same vulnerability, because probably is in the same shared code. And maybe you can think that affect only those two apps, but in reality is a very common error made by the developers, because also the application for Rai Television is affected. So they are again transmitting the password in plain text. So the problem is, why is this dangerous? This is dangerous because any node in the network between you and the server can see those passwords. So it's not only an attacker on your network or on your Wi-Fi. This traffic can be seen also by your internet service provider or by any internet intermediate node between you and the server. And it's your responsibility as an application developer to protect the password and sensitive data of your users, because the largest part of the user are not security aware, so they will often use the same password for everything. So if a password is leaked, the user is almost completely compromised, because they reuse the same password and they don't use stuff like two-factor authentication or stronger protection. So there is a stronger responsibility while you are developing. So how we can prevent this error? Well, it's not that hard. We do it for web development from years. We just have to use SSL and or TLS. And in our example, they were using HTTP request, so it's enough to switch to HTTPS with a valid certificate and don't pass stuff in get parameters, because if you pass a stuff as a get parameter, it will be so in the URL. And you must not disable certificate validation, because disabling the validation will nullify your effort made implementing this mitigation. There is a strong interest on Stack Overflow on how to disable SSL validation, and so I'm not gonna show how to do this because it's bad. And usually developers do it because they don't have a valid certificate, or they are using the application in a test environment, and they don't want they don't want to use to switch configuration in the code. So if you disable this, your security is pretty much compromised. It takes only a slight test advanced attacker. So what is certificate validation? Very quickly, it's a way that your operating system has to establish that the traffic is authentic and valid, and that it's signed by a trusted authority. Your device is shipping from the manufacturer with a bundle of certificate authority, like for example VeriSign or Apple or stuff like that. And when you buy a SSL certificate, you go to one of those and you buy a certificate signed by them. And you will use this certificate for the HTTPS traffic of your website. So when the traffic arrives at your device, this will be encrypted and it will be recognized that it's from a trusted source and not by an attacker which is man-in-the-middling the communication. So a man-in-the-middle attack, very simply, is just someone between your device and your server, which is capturing the traffic and sending it to the other part. So it's like a man in the middle, someone in the middle. And it's impersonating the server for your device and the device for your server. So just a quick summary for this very important practice is to use SSL TLS and so also use HTTPS instead of HTTP for your request, and don't disable validation. Buy a valid certificate. What about if you are a bank or something like that, that you need a very high level of security? I don't want that an advanced attacker, like government level attacker, is able to sniff my traffic. The solution is the certificate pinning, which is to very quickly bypass entirely the certificate validation and say to the application to trust only one certificate or only a set. So you restrict the set of valid certificate to only yours. And the good thing of this is that your certificate can also be self-signed, so you don't need to pay anyone for your SSL certificate if you use certificate pinning. If you want to a more detailed overview on certificate pinning, I suggest to you to take a look in this link, which is from the OWASP project. Now we pass to another vulnerability that is very common, which is when you save data on your device and you don't protect them. Before we looked at the data in transit. Now we look at the data at rest, the data that is persisted in on the device, like for example in files or SQLite database or core data or whatever. So you should, the best practice is to encrypt your sensitive data if you need to store on the device, or to don't store them at all, because usually they are not needed. A copy of sensitive data is not needed on the device. So if you can, try to not store on it, because the private folder of the application on iOS is protected by the sandbox, but the device are lost every day and they can be jailbroken. Now we have iOS 8, so at the moment there is no publicly available jailbreak, but in the few months ago we spent with a big window with 7.1 where there was available an iOS jailbreak, and it was also the latest version. So if someone potentially lost his device, an attacker can jailbreak it and can retrieve all the files stored by your applications, and also those files can be leaked in other forms like backup and stuff like that. So you should really not persist sensitive information in files if you can. And also, like I said before to you, the user always reuse password. So if you persist a password on the device and this is compromised, the user is compromised a lot of time. So iOS is a very nice platform because it provides to us great ways out of the box on how to protect ourselves when we store stuff on the file system and in the keychain. So very briefly, what we can use is to set a protection level on the files and on the keychain items. A protection level is essentially a policy which determines when something must be encrypted or decrypted. You can say, for example, I want this file always decrypted because I need it when I do a push notification, so it can arrive also when the device is locked. Or you can say, for example, that I want these files always encrypted when the device is locked because maybe there is sensitive data in it. So I want that when the user set a passlock, I want to respect the user, and so the user, when it locks the device, my files are encrypted and they are not possible to recover without bypassing without the PIN or the touch ID or whatever. You can they updated in September the iOS security guide, which is a document provided by Apple, which is very nice, and I really recommend it to you to read. Another stuff that you can implement on top of this is an additional level of encryption, and you can take a look at those projects like SQL Cipher or IMAS project, which they provide encryption layer, transparent encryption layer on top of SQLite and on top of core data. So you can add encryption to core data for free or to SQL Cipher. The APIs are exactly the same, except when you open a database, you pass a passphrase, and the database get opened in a decrypted form. Another very common error that I encountered is that developers tend to implement by themselves cryptography. This is very bad because cryptography is very difficult to get right, and you should only use tested and very popular library application developed by experts, because learning cryptography takes a life. And so if you don't want to do only that, you should use the public libraries. And you should not embed static keys or static password in the code, because an attacker can reverse engineer your application and retrieve your static keys, so they are just useless. What you can do is to ask the user for a PIN or a passphrase, like many banks do. And from this PIN or passphrase, you can use a passkey derivation function, and generate an encryption key from this passcode, which avoid brute force attack because it wastes by purpose CPU cycle. So what you can see here on the right is a demo that I will show to you in some minutes. It's from a Money wallet, which protects the content with a PIN, but the cryptography is broken, so it can be cracked with only 12 lines of Python. So later we will show, I will show to you a demo. On iOS, we have also other channel of leakage of information that are typical to the iOS platform, which are the caches and keyboard caches and NS logs, or application snapshot and the cut and paste. So here, very quickly, I will show to you. This is a screenshot from my bank application, and even when I was logged out, when the application went to background, a screenshot was taken. So it's possible to retrieve all the kind of information from my bank account, even if my session was expired. So you can mitigate this using the callback of iOS. When your app is entering in the background, you can sanitize the view or cover it with another layer, and the screenshot will not contain any sensitive information in this way. With, as we saw with the presentation of iOS 8, the iOS operating system is changing a lot from the side of inter-process communication and openness of the platform. Now it's possible to create extensions, and app can communicate more, I'm scared to say this, more in an Android way, because it's very similar to what Android was doing from some times ago. So this is a whole new attack surface, and we must be careful, because before the iOS application were very closed, so there were only few points where the data could come in, untrusted data, sorry, could come in, so we were less exposed to attacks. So what we must be careful with are custom URL schemes, because our app can be invoked with a custom URL if we declare it. So those are untrusted data, so an attacker can potentially inject with those custom URLs data, malformed data, and trigger eventual vulnerabilities. With iBeacons, we must be careful, because an iBeacon's ID can be spoofed, and so if an iBeacon is triggering costly actions in our application, this can be spoofed, and our application can be tricked. And as I said before, now there are extensions, so we must take into consideration that our application can communicate more with other ones. iOS native applications are compiled in native code, so you have all kinds of compilation flags, and luckily the new Xcode defaults are quite good. So if you have a new project, you are almost good. But if you have a legacy project, I listed to you some things that you should look for to improve the security of your application. And the first one is to look for that you are generating position-independent executable, and that you have ARC enabled, because position-independent code makes harder for an attacker to find in memory your code, so it's more difficult to write exploits for your application. And ARC not only improve the not only improve the development of the application because it's easier, but only it improves the memory management, so it reduces the bugs related to the life cycle of the objects, like use after free. And also you can enable this compiler flag to protect your stack buffers from overflows. How do we reverse an iOS application? We need a jailbroken device and a couple of tools. The first one is simple tools that you can find in Xcode, and it will dump the headers and the properties of your applications, so an attacker can start to understand the logic and the structure of your application, taking a look at your interfaces. The second one are two disassemblers, which one is Hopper, which is very cheap, that I show to you here, and it can take a binary and can disassemble it or decompile it. So an attacker can start to reverse engineer the logic of your application, like I will show to you in some minutes in the demo. And the other one is equivalent, but it's more expensive, and it's a more professional tool, with is IDA Pro. And CRYPT is another tool that I will show to you later, which allows an attacker to manipulate your application at runtime. So what is the flow of an attack usually? An attacker usually downloads the application from the App Store and it decrypts it because Apple applied to the application in the App Store DRM. So the application is encrypted, but if your device is jailbroken, you can run your application and attach to it in a debugger, with a debugger, and you can dump the memory while it's decrypted. So you can obtain again a decrypted executable that you can reverse engineer. After that, you can pass this decrypted executable to class dump and obtain a similar, this is only a piece of the class dump output of a single view controller, but you will obtain all the class structure and headers for Objective-C code and Swift code. With Swift is a little bit different. Now we are just at the beginning of Swift reversing. Swift is very new, so the tools for reverse engineering it are a little bit behind. And like I showed to you in this screen, Objective-C exposed to an attacker a lot of metadata, like variable names, property names, method names, because it's a very dynamic language. Swift is a little bit better about that, but it's still very rich of information. As you can see this, if you want to experiment with Swift reversing, you can download the VuvuDC application, which embeds inside of it some Swift code. It's probably the only application yet in the iOS App Store. And it has a Swift inside, and as you can see, the class name are a little bit scrambled, a little bit mangled, but an attacker can start from here and demangle the names based on some conventions. So it's not really an obstacle, it's not really an improvement if you develop your apps in Swift instead of Objective-C for security. So what I suggest to you against a reverse engineering attack is if you have intellectual property very important in your application, is to code the critical part in C instead of Objective-C or Swift, because the compiler will greatly optimize C and it will remove a lot of information from this C code. And so an attacker in the binary will only see a big mess of assembly instead of very well structured Objective-C code. And if you want to do even better, you can keep an eye on this research project, which is an obfuscator for LLVM. LLVM is a project among which there is a compiler, and this obfuscator work at LLVM bitcode level. So your compiler front end will take your Objective-C and translate it to LLVM bitcode, and then the obfuscator will kick in and obfuscate this intermediate representation, and then the compiler backend will generate valid obfuscated ARM code. It's already used in some projects, but it's quite experimental yet. It was used by the evasion jailbreakers to obfuscate their application, to take more time for Apple to reverse engineer their jailbreak. Here I will show to you the demo. This is Money Lover. It's the wallet that I talked to you before. It's a very simple wallet which you can insert your stuff and track your expenses, and you can protect your stuff from unwanted eyes with a pin. So now we reverse engineer what they are doing. Here I reverse engineered their algorithm to hash the pin, and I cleaned a little bit the code. As you can see, it's not perfect, but it's normal. It's just important to understand the logic behind it. We don't want to have a fully working code. So what they are doing, they are just grabbing the pin and they are just calculating the MD5 of it, and they are comparing it with MD5 that they are stored somewhere. So and if this pin is correct, they are dismissing the view controller, granting you access to the application. So how can we attack this mechanism? Well, we have two obvious ways. The first one is that we can dismiss by ourselves the view controller by attaching with a debugger to the application and hijack the code and simply dismiss this view controller. And the other one, we can query the application for the valid MD5 and we can crack it brute forcing, like I will show to you, because it's the most interesting part with this 12 line of Python. Now I will show to you how I can retrieve. Sorry. Okay, now I'm attaching to my iPad with SSH, and now I will find my Money Lover running application on my iPad. I find the process ID and I attach to the application with the Cycrypt tool, which is essentially a tool that is similar to a debugger, but it provides to you a REPL interface. So you can write a mix of Objective-C and JavaScript and invoke a method on your application. As you can see, here I retrieved the database controller from a static method. It's a singleton, so it's easy to retrieve the shared instance of the running application. And now here I will allocate the staff to query their database for the password, the hash of the password. And here I will do the query. So the application is providing to me the result, like I'm executing code in the application, so I'm invoking method and it's returning to me the answer.
The iPad is jailbroken.
Yes. Yeah, the question was if the iPad was jailbroken. Yes, it's jailbroken. Both because to run SSH server and the other tools you need a jailbreak. So here there is the hash that I just queried from the application, and it's just enough to run this tool, which takes less than a second, and Python is very slow to do this stuff, so the cryptography is very broken. What about Touch ID? Apple opened Touch ID to everyone, which is great, with local authentication framework, and it provides to developers to be notified if a user successfully authenticated with Touch ID or not, and it will be cool to use it in our application. So after the demo that I showed to you, I ask if you can spot the problem here. So basically we have two branches of code. One is taken when the authentication is successfully, and one where it's not successfully. So if I show it to you in the demo before that an attacker can influence the code taken by your application, you can understand that as soon as all the code run on your device, this code is vulnerable to hijack, and so an attacker can bypass this kind of protection and code, because you are not asking the user for an information. So what you must do is do like Apple does. So they ask at least once the passcode to the user. When you power the device, you can't log in with the Touch ID only. So this feature must be used, but carefully. It's not a silver bullet to provide login to our application. So maybe a little bit better is KEYCHAIN access control level, which they integrated with Touch ID. So you can, for example, store a password in the keychain, and you can say to the keychain to give it back to your application only if the user authenticates with the Touch ID. So the password will be safe in the keychain, and it will return it to you only if the user authenticates. There is this nice session in the last WWDC, if you want know more. Now I think I finished, and I will show to you some online resources. Hopefully they are useful for you. And here there is a bignami of best practices for development made by the company where I work for, and they are like 50 best practices with resources, with the common errors and the remediations. Here there is the OWASP mobile project, which have a nice cheat sheet for developers and for application security testers. And if you want to learn more about iOS application security and iOS application reverse engineering, there is this very nice project which is called Damn Vulnerable iOS Application. If you are familiar with web security, there are all those kind of web service with vulnerability by purpose to make exercise. And so this is very similar, and they have a very good session, learning section, which provides to you very nice tutorial to learn. You can also get certified if you want. You can get this certification and put it in the curriculum to be a certified developer for security for iOS. If you want to give a try to this free product, also it's in the slides. And if I have to choose only one thing that to communicate with this talk, is that security is not a status that is reached and it's maintained. Security is a process, and it must be always assessed and checked. In fact, it would be good to insert security in the software development lifecycle. So, because security is a very rapid changing field, so your application can be secure today, but it can maybe not to be in the next future. There are a lot of iOS developers here, so if someone wants to help with an iOS project, there is this project called Radar, which is a reverse engineering framework, and we are trying to bring it with an user interface on iOS. For now, it's for a jailbroken device only, but maybe some days we will figure out how to make it available for regular devices. So you can reverse engineer binaries within your iPad or iPhone. So that's all. If you have any question, or I don't know how many time I have left.
Still 10 to 15 minutes.
Okay, I did quit. Okay.
Thanks for your talk, first of all. Most of the time you have to store like API keys or some sensitive strings in your application. What is the best practice to store it?
Yeah, I mean, you can try at the start, you can try to don't embed them entirely in the same place, because it's very quick to do just a strings command and dump all your API key. So you can embed them a little bit scrambled or encrypted. This is a very first step. So, but yeah, I don't know what, if you can contextualize the application, we can maybe find a better solution. But the best choice would be to don't embed any, for example, private key or stuff like that.
Okay, thank you.
Other questions?
On iOS there is the KEYSTORE. On the jailbroken device it is always secure, or there is some method to read data?
Yeah, you can dump the keychain in the KEYSTORE. And, you mean the hardware KEYSTORE?
Also the software KEYSTORE.
Okay, sorry. Because my first platform is Android, so I just I don't do anymore iOS development, so I just check for security of iOS application. But as far as I know, the iOS keychain is completely dumpable from a iOS jailbroken device. So yeah, but I mean, it's an entirely different game if you are considering a jailbroken device, because if a user, like I showed to you in the first slide, if a user jailbroke his device, your entire security is compromised.
Any other questions?
About the TOUCHID, is there a way for my app to be sure that the TOUCHID is not sent to something, say to Apple or to someone? Like sniffing the network and to be sure that the TOUCHID does not exit from my device, from that device.
Okay, it's a device. You are asking a device-wide question, not of your application, or because your application just get notified when I authenticate myself with a fingerprint. So I mean, with a Touch ID, you just get, okay, I'm authenticated, okay, I'm not authenticated.
But can I guarantee some TCP dump inside of my app just to similar to that I can see if this Touch ID go out?
But
because I think this is a problem, because many people are scared about Touch ID because Apple says that it is not sent to the servers, but
okay. Yeah, there is. I suggest to you a talk by one of my colleagues about Touch ID. If you want to take a look at it, it's like a world expert on this. His name is Andrei Belenko, and he made a talk about this and about the iOS cloud service. But for example, these operations are all cryptographic, so those kind of information should not be sent to Apple. They deployed this like trust zone inside of the GPU where this operation take place. So even an attacker inside of the device should not be able to interfere with this. So.
Any other questions? No? Okay. Then we are done.